You're watching Billy the Science Guy. Today is a great day to be talking about science. In my video, I'll be explaining the importance of gases in the human survival and recreational use when scuba diving and deep sea diving. If you happen to be in the grade 11 chemistry, and I bet quite a few guys are, there are a few text references from McGraw-Hill Chemistry 11. The main text reference is 11.3, gas application. The other two references are 11.3 and 11.2. 11.3 is gases and temperature changes, and 11.2 is gas pressure and volumes. Throughout the video, I will explain several things. The first thing I will explain is what is scuba diving and deep sea diving. Following that, I will give you a general description of the gear needed to scuba dive and explain in detail two pieces of equipment: the exposure suit and main scuba cylinder. Following that, I will explain about the dangers in scuba diving and some advantages of going scuba diving. Finally, I will conclude by explaining about professional divers, diving in Canada, and Ontario initiatives towards diving safety. The word scuba is an acronym for self-contained underwater breathing apparatus. Deep sea diving and scuba diving are extremely similar, so for the purpose of this video, we will consider them to be the same. There are many reasons why people would go scuba diving, whether it's for their job or for entertainment. When scuba diving, there are many pieces of equipment to consider. The first piece of equipment is the face mask. The face mask is needed because the water transmits light differently than it does in the air. So what the face mask does essentially is it maintains the pocket of air in front of your face while you dive underwater. The next piece of equipment is the fins. The fins are an important piece of equipment because it allows the divers to maneuver around the water more easily than with their legs and their hands. The weight belt is what the diver needs to sink into the water. And why don't they sink, you might ask? Because seawater is denser than fresh water and people float on fresh water. But how do I know that seawater is denser than fresh water? It's because seawater contains sodium chloride, and sodium chloride is denser than water. Therefore, seawater is more dense than water. There are two types of gauges, the content gauge and the depth gauge. The content gauge is what the diver needs to tell him how much oxygen he has left, and the depth gauge is what reads the pressure of the water on the diver to tell him how deep he is. The BCD is an acronym for the buoyancy compensator device. What this device does, it is just the flow of gas in and out of this compensator to allow the diver to float or sink. The last piece of equipment is a demand valve. The demand valve allows fresh air into the diver when he inhales. While diving underwater, you should wear exposure suits. Water conducts heat 25 times better than air, so you should wear these suits. Liquids conduct heat better than gases because they are denser than gases, so in order to maintain your body temperature while underwater, humans have to wear these exposure suits. These exposure suits also help protect against abrasions, cuts, and animal stings. And just to name a few types, there's the wet suits and semi-dry suits. And these are the common types of exposure suits. These suits are made out of closed cell neofoam, which is a polymer made from acetylene and hydrochloric acid that have been expanded with nitrogen bubbles that are trapped inside the rubber but are not next to each other. And what this does is it makes sure that the suit does not absorb water. The other type of suit is the dry suit. The dry suit keeps the diver dry while underwater. It is made out of the exact same material as the wetsuit, but it keeps the diver dry, like I said. The dry suit can be either skin tight like the wet and semi-dry suits, or it can allow gas to be pumped into the suit to keep the diver warm. If the dry suit is skin tight, the diver would have to wear clothing underneath to keep his body heat. But if the gas is pumped, he doesn't have to wear that much clothes because the gas, usually being argon, that's what the professional divers use, or conducts heat 25 times less than air does, so heat does not escape the diver's body as easily. Humans breathe air, and to bring air with us underwater, we need the main scuba cylinder. They're usually called tanks or bottles, and they are manufactured to come in different sizes and pressure ratings. These tanks range from 16 to 18 liters in size, and the tanks fill up to about 3,000 psi, which is about 21,000 kilopascal. But the pressure doesn't remain constant. Guy-Lussick law states that the pressure of a fixed amount of gas at a constant volume is directly proportional to its Kelvin temperature. So as the temperature drops, the pressure would drop proportionally. And similarly, if the gas is heated, the pressure would rise proportionally as well. With that in mind, these tanks would have to be handled carefully because the tanks are usually made out of aluminum and not steel, making it extremely easy to dent. Atmospheric air contains 21% oxygen and 78% nitrogen, and 1% other gases. Inside the gas tanks, it would contain about 32 to 36% oxygen, which is about 11 to 15% more oxygen than normally found in the atmosphere. The high percentage of oxygen would mean a lower percentage of nitrogen. This kind of gas is called enriched air nitrox. This gas helps reduce the probability of decompression sickness and increase the amount of gas that cause oxygen toxicity after a maximum operating depth. You know that the seawater is salty, right? Well, it is. I said it in the previous part of my video. In the movies, you've seen submarines dive deeper and deeper into the sea and get destroyed by the pressure.
Dive to 300 meters.
300 meters is supposed to crush that.
Well, what might this pressure do to the divers as they go deeper into the ocean? There are a few negative effects. Decompression sickness, the DCS, is caused by a reduction of pressure that would result in the formation of bubbles in the body. There are two factors that would affect the sickness or the risks of a diver suffering from DCS. The first is the rate and duration of the gas absorbed under this pressure, and the second is the rate and duration of the gas going out during the depressurization. That isn't the only thing that might happen to you if you go diving. If you go below a certain level, you might get oxygen poisoning. Oxygen poisoning happens at about 1.6 bars. The gas in the lungs must equal to the pressure of the water around the diver, so as the diver descends, the pressure in the lungs will match, so that the lungs do not collapse. Other risks might include that you'll get chafing on your skin from the rubbing of the wetsuit or dry suit, or that somehow you lose your oxygen tank. Before you get another phobia, know this: diving isn't all bad. There are plenty of good things you can get from diving. You can get the experience to try something new, to learn it. You can go and meet exotic animals, play with dolphins, explore shipwrecks, and meet new people. Other than recreational divers, there are professional divers who make a living scuba diving. There are three classifications of these divers, which are the commercial, the scientific, and the military. The range of these dives would go way beyond the safe limit of using nitrox, so they would use a different gas called trimix. Trimix is similar to nitrox as that they both contain oxygen and nitrogen. But what is different about trimix is that it also contains helium. By adding this helium, it would lower the oxygen level and therefore reduces the chance of oxygen toxicity as the diver goes beyond the safe limit of nitrix. Another thing I'd like to mention is the rebreather. It is a breathing apparatus that is mainly used in the military for the fact that it does not produce bubbles. The rebreather does not produce bubbles because it takes the carbon dioxide that you exhale and it does not release it into the water, but instead it brings it back and mixes it up with a can of sodium hydroxide to produce oxygen, the thing you breathe, and calcium carbonate. By doing this, the rebreather recycles the oxygen for the diver. Scuba diving can be an enjoyable experience. In Ontario, the Ontario Underwater Council promotes a safe diving community. The council has implemented several initiatives to do this. The Averill Birth Memorial Project is to promote boater awareness of the two diving flags. The Scuba Diver Safety Awareness Project is an initiative to reduce the number of fatalities at the Fathom 5 National Underwater Marine Park. There's also a vessel inspection program, which is an initiative to inspect and report the conditions of the vessels that plan to be on Ontario waters. This initiative provides recommendations to the drivers about diver safety and enjoyment. In Canada, there is a commercial diver school. At this diver school, they emphasize on hands-on practice and hard work. It shows that knowledge of the gases isn't good enough to become scuba divers, but you need practice to make perfect. Thanks for watching my video. And that concludes my presentation. I hope you learned as much as I enjoyed presenting to you guys. If you guys want to see more videos, don't forget to subscribe. Scuba diving, to use the face mask, you put it onto your face.